Good day. This is Dr. Amudapriya, Associate Professor EEE from Rohini College of Engineering and Technology. We are discussing about the course Power System Operation and Control, and we are going to deal with the lecture on requirements of a good power system. Normally, let us start with the process of generation, transmission, distribution and the utilization systems for lecturing about the requirements of a good power system. Here we do have the location of the electric power plant, which is being normally decided based upon its fuel base, that is the coal, gas, water availability. And next, the huge power generation cannot be consumed in the area where it is being generated. So it has to be transmitted over a long distance by increasing its voltage level. That is, we have to step up the electricity. And after being transmitted, it has to be supplied or distributed at places depending upon its requirements, where we have to step down the electricity and then we have to move further on the distribution base. And at the consumer level, we do have several consumers based upon that. I mean, there may be large consumers which may directly consume the electricity from the distribution substations. Where it is being converted to 33 kV to 11 kV conversion will be there. From that, they would directly, from primary distribution, they'll be directly purchasing the electricity. Rather than that, other consumers will be connected to the secondary distribution transformers. So these are some of the voltage levels where the generation, transmission and distribution will be taking place. This is what is a single line diagram of a power system representation. We do have generator where the electricity generated is at 33 kilovolt. For the transmission purpose, it has been stepped up to 132 kV. In other countries, we do have 220 kV, 400 kV, etc. This electricity transmission with large voltage will avoid the losses to a great extent. And at the distribution side, it has been stepped down to 33 kV and it is subjected to secondary transmission there. After secondary transmission, it may reach the distribution side, where at the primary distribution substation, it has been stepped down from 33 kV to 11 kV, and after that it is being sent to the secondary distribution side, where the 11 kV is then stepped down to 400 volt or 230 volt. Depending upon the consumer levels, we are being supplied. The three-phase consumer may consume 400 volt directly. Others, the single-phase consumers may consume 230 volt accordingly. So the generated power is transmitted and distributed through overhead transmission lines, also through underground cables. The transmission voltage level is very high and the distance between the generation point and the receiving station is also very high. So for transmission of power, overhead system is being adopted than the underground system, considering the voltage drops and cost involved. The generation, transmission and distribution is exclusively three-phase in nature and only 3 conductors are required there. Utilization network can be 3-phase or single-phase. So it requires 3 or 4 conductors depending upon the availability of the neutral conductor. 3-phase 3-wire system, this requires 3 wires or conductors for distribution. It may be in star connected or delta connected form. If star connected, then star point is then connected to the earth at 0 potential. Load must be of 3-phase nature and balanced, that is, magnitude of current should be same in each phase. An electrical load is a single phase nature. The electrical load, a single phase load cannot be connected there. While considering the 3-phase 4-wire system, this system requires 4 wires or conductors for distribution. It can be connected in star connection only. The star point is connected to the neutral, it is being grounded, and an electric load of either 3-phase or single phase may be connected here. Regarding the earthing, the potential of the earth is considered to be at 0 for all practical purposes. Earthing is to connect any electrical equipment to the earth with a very low resistance wire, making it to attain earth's potential. This ensures the safe discharge of electricity, which may be due to several reasons like insulation failure, when a line is coming into contact with the casing, etc. Earthing brings the potential of the body or the equipment to zero. That is Earth's potential. Thus, it protects the personnel who are operating near the equipment or something else. This is how an electric power system is there. The generation side, next the substation, transmission, and then the substation where it has been stepped down, and finally it has been supplied to the load accordingly. So we have to see about the earth resistance at each and every level. The earth resistance is affected by the following factors, mainly the material properties of the earth wire and the electrode, then temperature, moisture content of the soil, depth of the pit, and the quantity of charcoal used. So in all such cases, proper maintenance has to be made. Otherwise, there may be a shock to the person who is being operating there. If the insulation is not healthy, then automatically it will be affecting, the person who is operating over there will be given immediate shock, electric shock. So the insulation should be healthy. The supply current should flow through the resistance of the apparatus only, not other than that. No current flow should be there through the body of the resistance, through its body. The person should be safe enough if the apparatus is not being urged. So these are all some of the necessary conditions which has to be exhibited in case of an electric power system. Main reason for earthing is to protect the personnel from danger of shock in case if they are in contact with the charged frame due to defective insulation. Also to maintain the line voltage constant under unbalanced load condition. This is one of the most important criteria. And next, in order to protect the equipments and the large buildings and the machines against the lightning, etc. There are several different methods of earthing, namely plate earthing, pipe earthing, rod earthing, stripe or wire earthing, etc. The difference between the earth wire and the neutral wire. This is one of the major concepts which do confuse anyone, a student or faculty or a individual person or whoever be. They have a small doubt. What about the difference between the earth wire and the neutral wire? Here we can have a clear explanation of what is it. The neutral wire is in a 3-phase 4-wire system. The fourth wire which is connected from the mid of the star point. At the star point, it will be the starting point and will be connected to the ground. This is what is called the neutral wire. It acts as a return path for the 3-phase currents when the load is not balanced. In domestic single-phase AC circuit, the neutral wire acts as a return path for the line current. But earth wire is actually connected to the general mass of the earth and the metallic body of the equipment. Its main purpose is to provide a transfer of any leakage current from the metallic body to the earth. So this is what is the main difference between earth wire and the neutral wire. So these are all the requirements of a good power system. Thank you.